super short introduction for this one. We are going to be creating the portals, in other words, the exits for the room, and also the keys. So the things that get shown up there. And there's been a lot of technical difficulties, and it took me quite a while to get this one out. So different change of shirt as well, as you'll see in the video. But hopefully you enjoy it. So let's get started after the fade. Okay, so the last time I took a look at this project, it didn't record. And the reason why it didn't record is because, and I kind of alluded to it in a follow-up video, the whole technology let me down thing. To be perfectly honest, it was me. I let me down. The settings for, let me just make sure I'm recording this. Yeah, I'm recording it. The settings for OBS, it defaults to FLV files, and apparently FLV files constantly write to the disk when you're recording. So if anything happens to the project, OBS crashes or the machine reboots or whatever reason, you still have the recording. Now, in order to make it a little bit easy for me to put this into Adobe Premiere, whatever you want to call it, I chose to record as MP4, and MP4 does not have that ability. It's an all or nothing thing. So when you stop recording, it takes a long time to take that buffer and then write that out to the file, and then that gives you the MP4 file. So in order to get around that, I've reverted to using the FLV version of the OBS, which means I have one extra step to do, which is called a remux of the video, which is built into OBS anyway. So, the problem is that I now have lost the video, so I have to come up with a sort of nice segue to do this. And what I'm going to do just now is I'm just going to show you what I came up with now. I've also had to update because it's taken so long to get this video out. Really? Okay, so this class does not use this. Okay, so yeah, it's about whatever it is. I'll figure this out in just a sec. All right. So what I came up with the idea of, and this is what this class here is, and I'll just remove some of this old code that I don't need anymore. Well, I'm talking about it. Is that this basically replicates the Spectrum screen. So when I write things to the Spectrum screen, I'm actually writing it to this buffer here. Everything is held, where are we? Inside this here, which is the texture screen. So this is the actual texture itself that gets displayed on the window. I also have a list of attributes. So if I go into ZX attributes, you'll see that we have ink, paper, bright, and flashing. These are the attributes for each 8x8 pixel character square. In the Spectrum, every character square can only have two attributes. It can have a foreground color and a background color, and that's it. It can't have any other descriptions in there. So that means that every pixel is either the foreground color or the background color, and there's nothing else. You can't have any other colors in there. There are other Spectrums that have other text modes and things like that, but in graphics modes, like the Timex Sinclair 2000, I think is, or whatever one it is, it has different graphics modes from the original Spectrum, but this game was written for the original Spectrum, so we only have two colors per 8x8 character block, which means that every time you write something to it, you have to make sure that it's the right color. So when I poke, this is what I call it in here, is I poke this value into memory. And I'm doing this for a reason, because in the back of my head, I'm thinking at some point I actually want to do a Spectrum emulator inside Unity, just as a sort of for fun type thing. So a lot of this is geared towards that kind of mentality, but it will help us when we're doing the game. So essentially, all of this code in here, so there's like 300 lines of code, including comments and things. All of this, and this is downloadable as well from the repository, so if you want to check the source code down below. And I'll update it after we get out of here. Get rid of this as well. All of this basically writes to a texture, which means that our renderer, our screen renderer here, so that's the Spectrum screen there. We'll get to the character screen. In the previous video, we're going to change that so that it now writes the Spectrum screen. The room renderer itself, if I just do that, the room renderer itself, we've just commented out the character screen for just now. It writes directly to the screen. So it sets up the attribute and it draws the sprite at that position. Okay, so that's what we're doing as far as drawing the objects. Is we're going to be using this screen from now on, which is going to add a bit of complication to how we display things, because everything is now going to be on a per pixel basis. So we're not going to use Unity's movements. So Unity's movements are done using floating point numbers, x, y, and z coordinates. We're going to be using x and y coordinates because it's an x and y screen. It's just one plane, but we are going to basically ignore the z value, and also we're only going to be using whole numbers. We're going to be using integers, so 0, 1, 2, 3, 4, minus whatever it is, rather than point whatever the values are. Okay. So that being said, what I want to achieve today is I was going to go through and sort of explain all this, but I've kind of commented the code, so it should be easy enough to understand what's going on in here. And the sort of trickier ones are sort of explained here. So this is determine the origin of the attributes. Seriously? Wow. There you go. You're in the middle of work and all of a sudden this pops up. Okay, I'm going to snooze that. Hopefully that'll snooze it for an hour and give us time to do that. So what I want to do is I want to see if we can get the bad guy. We want to get the baddies in here. That's my sort of goal for today. So again, if I change the room number here for the room renderer, it will display the current room number. And don't worry about the purple is actually the background color here. So when it comes time to actually like ship the game, we'll change that to black so that when we play it, we get the black background. But for now, I want to keep it as a sort of magenta color, so that we know that we need to do that later on. And also we can see the sort of outline of the screen there. And again, the way that we've done it as a texture is great because we can actually put it in the UI layer if we wanted. This is actually just, I think this is just on a, this is just on an actual sprite. Spectrum screen. Yeah, there you go, sprite renderer. So it's actually just on a sprite that's sitting in 3D space. So, and it works just as good. And we know the camera would set that all up so that it's 96 pixels high and all that kind of stuff, which is like half of 192. Or sorry, yeah, 192, which is the height of the Spectrum screen. Because every pixel that we've done is 1 unit in every one of these pixels in here. So that the point of that there is 1 Unity unit. So we sort of kept the math simple rather than trying to multiply things out and divide and all that kind of stuff. We just kept it as 1 unit, and then that's good enough. So I've kind of done like 10-minute recap here. What I'm going to do is I'm going to probably put a bumper at the start of the video and tell people that it starts a little bit later. But anyway, if you were interested in whatever. Okay, so what we want to do now is we want to take a look at, we don't want the conveyor, don't want the border color. We've got items and we've got portals. Maybe we could do the items today actually. Let's see what they, see. So I'm going to do items, and that takes us to items. Each room can have 0, 1, 2, 3, 4, or 5 items. Perhaps you call them keys or objects, but not all of the items actually look like keys. The item graphic is defined separately. And in my world, everything's an object. Okay. Up to 5 items can be stored in the offset 629 to 653. First item if present, second item if present, third, fourth, fifth. If there are fewer than 5 items in the room, then pad out the item after the last item with 255, and any item after that with 0, 255, 255, 255. Okay, so if you want to delete an item, remember to shunt the ones down. Alright, so here we go. So the first byte, second, third, and fourth bytes. Alright, let's do that. But first we'll get the item graphics. So the item graphics are at hashtag item_graphic. Item_graphic. The item's 8x8 graphics. Appendix B is held in offset 692 to 699. Note there are no color attributes associated with this. Color attributes associated with individual instances of the item up to 5 are stored in offsets, blah, 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 blah. Okay, so again, this goes back to the whole, the spectrum is your pixel is either on, which means it shows the ink color, or it's off, which means it shows the paper color. That's the only two options we have. So that's where our item graphics are. Okay. So I guess we just grab those item graphics then. The items 8x8 graphics, and this is for each room. Okay. Okay. So what is 699 minus 692? Wait. 699 minus 692. 7. Oh, okay. So there's only one shape. Okay. Not very bright today. I could have seen that from there, but never mind. Alright. Alright, so let's go to our room. Where is our room? Debug screen, debug mode. And then we have our room renderer, which takes in the room store. And our room store takes in this information in here. Okay, so that's the conveyor start. And then import the positions of the items. Oh, okay, yeah, I remember how we did this. Alright, so I'm going to put this over here for just now. And I'm going to put this here. And I don't need Solution Explorer for just now. Okay, so let me get this right here. Okay, so the color, conveyor, start position, conveyor. So conveyor belt is 4, the border color is that. Then it reads in all the items, position of all the items. So that adds in all the items. Okay, so we've done that bit. To do import the positions of the items. Wait, so we haven't done that. Key position. I'm pretty sure we have done that. Import to read short. Yeah, I think we have done that. Okay. And then the next one is the portal. Okay, so that's the location of the portal. Let's just check that. So portal 655 to 691. 655 represents the portal's color attribute. Okay, so let's do the portal. If I can spell. I'll move that up a bit so people can see it. So we get portal. So our color attribute is going to be importer.read, gives us a byte, so that's going to be byte portal color, and then offsets 659 to 689 represents 16 by 16 graphics of the portal. Okay, so I think we have an importer for that, don't we? We have an importer, read bytes 8, reading the block graphics. See, yeah, we should probably do an importer that reads in 16 by 16 graphics, but I don't think we do. Reading the block graphics, reading the first byte represents the attribute, reading the next 8 bytes represent the shape. 8, and then blocks, attribute block data. So I think we need to do something similar to that. So that is going to be byte portal shape, we'll call it, importer.read bytes, and then we want to read in, well, it's 16 by 16, so that is 8, 16, so 32. 32, is that right? Yeah, because it's 4. Let me just calculate that again. 68 minus, this is why we have calculators, 31. Okay, so it is 32. So 32 bytes for the portal shape, portal shape. We've got our portal shape in there. And then 68 to 69 represents the position of the portal, a 32-bit word following the following format. Okay, so that is this one here. So this is our portal pause raw, and then our portal position is going to be from that portal pause raw, which is the get x and get y, which is what we worked out in the previous but one video, I think. But basically these are extension methods. So if I go to F12, you'll see that this is the Spectrum short extensions that file that I created. So to get the x value, we're taking off this amount of bytes, these bits here, and then for the y, we're taking off these bits. 1, 2, 3, 4. Blah, blah, blah. So that gives us our y value. And I think that works. Yeah, I think so. Okay, so what we want to do is we want to do data.add portal, and we're going to add portal color, portal shape, and then we're going to do portal pause raw dot, I'm going to make this bigger, dot get x, portal pause raw dot get y. Because we don't have that, I am now going to do generate method, and then I'm going to press F12, and that's going to take me to there. And this is going to give me my value. So cell point is that, so I'm going to call this public portal get set. So again, I don't have these values, I don't have that class, so I'm going to create that class here, and I'm going to call it add, and I'm going to call it portal. What? What? Well, I'm pretty sure that is Unity editor script. Is that all they've got in here? Okay. So we don't want a mono behavior. We just want a plain old editor script. I guess this has changed in Visual Studio 2017. I thought I was adding the full version, but clearly it's not the full version. Ugh. Okay. The things you learn. Okay, so this is my thing in here. And I don't want that. The heck is all of this? I just want a class. Well, this is awful. Ugh. I just want a plain old C# class. I guess I'm not getting the plain old C# class. Okay. So I want to add this portal here, and my portal is going to be. Do I have these as what do I have as cell point? Yeah, okay. So I've got them as integers. Int x get private set, and then I've got public int y get private set, and then I'll need to have the shape. So the shape itself, so that's room data, room key, dictionary blocks. So I just have them as a byte array. Okay. Byte. I'm going to call that shape. And then what else do I need? Shape, color. Okay. ZX attribute. ZX attribute. And yep. I'm going to call that attribute private set. Okay. So that's my portal. And I don't think I need anything in here. And then my constructor, I'm just going to make it as a plain old constructor here. I'm going to take in the, I'm going to take it in the same order as this, just to sort of keep things a little bit consistent. Just to make it a little bit consistent, so because you know you don't want to start mixing and matching your portals, your parameters. And then I'm going to do get x equals x, y equals y, shape equals portal shape, and then attribute equals new ZX attribute, and then that takes in int paper. So can I do portal color dot get ink? No. How did I do that? Where am I using these? Sorry, it's been a while since I looked at this code. Seriously? That's all I use? That can't be right. Attributes, ZX attribute, attribute, attribute. No, I guess I don't. So how do I get that color then? Okay. So okay, I'm gonna add a portal color. I'm gonna add that constructor in just a second, because I do actually want to make it not have this, because this is great for if we're doing something internally inside this game, but if we're just reading the data files, then we need to have another attribute, another constructor here. So I'm going to do public ZX attribute byte raw attribute. So I'm going to make this a raw attribute, and it's going to be constructor, and this is going to be a raw ZX spectrum formatted attribute. Okay, and I'm going to go refer back to here because there is an appendix. So here's the color attributes. So here is the color attributes for the spectrum. So we've got flashing, bright, paper, 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 ink, ink, ink. Okay, so our ink color is going to be raw attribute and OX07. So OX07 is 7 in it's hexadecimal, but 7 in hexadecimal equals 111 in binary. Okay, so paper is going to be raw attribute shifted 3 spaces, because our paper is paper, 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 which is there, and we want to shift that down to this position, and then we want to AND it with that, and that gives us the same result. So our flash, our flash is going to be raw attribute and then it's going to be the 1, 2, 4, 8. So it's going to be and OX80 equals OX80, because 8, that is OX80 equals 10000000 in binary. I think I've got the math right. And then I'm going to do the exact same thing for bright, but I'm going to cheat because I'm going to shift it 1 to the right. So I'm going to say bright equals raw attribute, shift that 1 bit that way, and then I'm going to AND it with OX80 equals OX80. So for the same reasons, and it just makes it a little bit easier. I mean, I could have put the 1 there and then check to see that, but maybe if this doesn't work, we'll go back and try that again. But that should work there. So our ink is our 3 most rightmost bytes. Our paper is the next 3 bits. Sorry, ink is our 3 rightmost bits. Paper is the next rightmost bits. So the left, you're going left from that, so that's the 3 bits there, and then you get flashing and bright. So flashing's the end one, and then bright's the middle one there. So yeah, that's our attribute there. And now when we go to our room renderer, we can draw the portal. So we can do screen.set attribute, and then we can specify an actual attribute. So in this case, it's going to be data.portal.attribute. And again, we don't have that method. We'll do that in just a sec. And then we're going to do screen.drawSprite, and then it's going to be our data.portal.x, data.portal.y, and then data.portal.shape. What is that not like there? Oh, it doesn't like rows. Okay, so rows, columns is 2 and 2. Okay, because we've got 2 rows and 2 columns of shape data. And now our set attribute, I'm going to do generate method. And then, so here's the problem, is the set attribute in here. If I go and find the set attribute down here, so we have a couple of set attributes. Let me just change that to void, because I'm not going to use fluent. And then I've got this one down here. So what I want to do though is I want to have, this can be public, but I want to pass it in as our x, y, and z. So that's going to be int x, int y. And that's right. So set attribute, and I need to do the same thing here. So this can be data portal y, and that there, y data portal attribute. Okay, so that's our attributes there, but I think I actually want to have extension methods for our ZX attribute. I don't know if I want to have them as static methods, but yeah, we should maybe take these out. So let's make them static methods. Okay. So I'm going to create methods. I'm going to call them up here and do public static get ink. Public static int get paper. Actually, that would be attribute, because all of these are going to be attributes. I just realized I was muttering there just as soon as the AC kicked in. Int, actually it would be bool get flashing byte attribute. Public static bool get bright byte attribute. Okay, so all I need to do is for bright, I want to do return. That's going to be attribute. And then for flashing, so basically these are all, I'm going to copy and paste this out here, and then we can use this elsewhere. So paste that in there, paste that in there, paste that in there, and then that's going to be return. And then this is going to be return for paper. And we'll sort these out in a second because I think it's trying to convert things to integers and it doesn't like it. That's attribute, that's why. And then this one get flashing is going to be this one here. And then that's going to be return, and then that's going to be attribute. Okay, so now these are all static methods. What I'm going to do now is I'm going to change that to this call here. I'm going to do get ink raw attribute. I'm going to change these all here as well, just to keep it consistent. That way, if any failures happen, then and then that's going to be get flashing. That's going to be get bright. And that's going to be get paper. All right, so everything is good there, and then that means that when we go to our, so I'll just recap that. So I made everything a static method, and then down here, instead of having it inline, I called the static method. What that means though is that I can now use those static methods inside our, where's my, is it the renderer? No, inside Spectrum screen. So inside Spectrum screen, I have a set attribute with attribute here. So now what I can do is I can actually call set attribute and then pass in our x or y, and then it's going to be our attribute, be zx attribute dot get ink, zx attribute dot get paper, zx attribute dot I don't need it there. What am I doing? I just need to do attribute dot ink, attribute dot paper. I don't know what I was thinking. Whatever, we have those functions now, which is handy, I guess. Bright attribute dot flash. Okay. So we have those attributes there, but for our portal, we actually need to do for int p y equals 0, py less than 2, py plus plus. For int px equals 0, px less than 2, px plus plus. And then we want to do plus px plus py because it's a 2x2 block, so we need to make that make that a little bit more explicit. It's a 2x2 block, so we want to change the attributes for 1, 2, 3, 4 squares. So this should, if I build this, it should yield no errors. Oh, didn't like it. Okay, this is the changes I made here. So I'm going to change all of these to void. And then get rid of that. Actually, I think I did this. I'm going to have a conflict thing. I think I did this on my Mac, and I didn't change it over onto the other one, which is going to be a pain because now I have all these things in here. Ho hum. So just give me a sec. I'll fast forward this. And we're back at 38 something. Okay, so we go to the game. Hopefully the portal will draw. No reference. Because we never set portal. Okay. So in our room data room store, we've got rooms, then we've got data add portal. So we go to portal. It doesn't actually add the portal, so we need to do portal equals new portal. Portal color, portal shape, X and Y. Okay. So that compiles, and then we run it from here. And we get the portal, but it's not in the right position. So the portal's over here, and you'll see that it's picking up the attributes, but that doesn't look like it's the right one. So if I go back to room 0, yeah, it's not picking up the right. That doesn't look like it's the right data. Which probably means I don't have the right information in there. So import the positions of the items. So that adds all the room keys, and then that reads in. Is that right? Let's check and make sure that's correct. Portal. Okay, portal. 655 represents the attribute color. 32 bytes represent that. 6. It's a 32-bit word. It's an integer. That's why. That's the position. So that's going to be read. Do I not have an integer? We do now. Return reader.getInt. Read int 32. Okay, there is read int. Read int. So that gives us our shape. That would be int which means this doesn't work now because these are all the wrong values. So we're gonna have to figure this out. Ugh. I should read this a bit more carefully. Both YYY and XXX are duplicated. 690 and 691 are informationally equivalent to 688 and 689. Secondary graphics buffer. Let's make sure Y, the most significant bit, is the same and make as that. Okay, so basically we have to read one short, and we're going to fudge this a bit. So this is a bit of a fudge because we're gonna ignore the first short. So it was right the first time. So short equals read short, importer dot read short. So that gets us in the right frame there, but I still think that we're getting the wrong. It definitely doesn't look like the right shape, and also I think that's the this isn't the right position. It should be over here, and that's definitely the wrong shape. But it does look kind of like it. Let me bring up the Manic Miner screen. Cavern. Ooh, somebody's done it in 3D. Cool. I'm guessing voxels or something. That's pretty clever. Okay, so here's the central cavern. So you see that this is. Let me just blow this up. Oh great, you can't see that because it's way hidden over here. Okay, so let me zoom in here. A little bit over here, a little bit over here. Okay, so you can see that this is, it's supposed to look like a kind of 3D boxy type thing. And clearly we don't have a 3D boxy type thing there. That's clearly not the right graphics. So, yeah. I wonder if we can do like a seek to that position just to see if we have that one. So if we do importer.seek, oh we do, okay. And then the offset is going to be the current offset. So read bytes there, read in there. What do we do for that one again? Room data now, room store. Where's the seek? Room store. Room data is. What's my seek? Nope, it was right the first time. Room store. Snapshot importer seek. Is offset that. Seek offset, seek origin begin. Okay, so it's seeking from the start there, whatever the offset is. And that is called, where's this called from? Is offset. Move to the next room. Import room. Offset. So I don't know. Oh, I do know. Yeah, I think I do know. I don't know what the offset is. Okay. Well, I mean, I can guess what the offset is. I can do int current offset equals importer dot get offset. Oh, I haven't exposed that. Yeah, okay. Maybe not then. Alright. So this one is reading in the block graphics. I get rid of that there because we don't use it anymore. We don't need to apply to the texture. Reading in the start position, so reading 1 byte for the Y offset, 1 byte for early start. That's the start position. Conveyor belt is 4 bytes, is that right? Conveyor belt, direction and position of animation, conveyor. Conveyor is 4 bytes, so 23, 24, 25, 26, so 4 bytes. So 4 bytes for that, and then after that is the border color, which is 627, which is right. And then and items, which is that there. See, we don't want to continue. Do we want to continue? Yeah, we do want to continue. Actually, we want to continue. We want to continue because we want to keep looping, because we have to loop through the 5 attributes, and that gives us the right number of items, because according to this, first item if present, second item if present, third item, fourth item, fifth item. So each one of these is 5, and if we look at this one here, you notice there's only 1, 2, 3, 4 items, which means we're missing a 5th one, which means we're 8 bytes out, or however many bytes out are in here. So I think this should give us, that fix there should give us, with the continue rather than the break, that should give us the right. What? Okay, I guess. That should give us the right value, because we shouldn't be continuing, we should just be ignoring, because we will always have room for 5 slots, we just won't have 5 keys, for example. So, but we always have slots for 5 keys. Okay. That did not help. Alright, let's see what's happening here. Okay. Time for some debug. Okay. So the raw position is, well, that does not look good. What is that in hex? DBB6. Okay. So we'll go to here, and we'll go to here. Okay, so F10. So that temp becomes 16, which is 22. So our X value becomes 22, which does not seem right to me, because it should be 30, it should be like 28. But I think the Y looks okay. The Y looks like it's the right position. So temp is that, temp is 13. So temp is 13. So that looks okay. Okay. So what's the issue with this? Right, so portable. So that is our X and Y. So our X is 1, 2, 3, 4, 5. So I think our X should be, what is that? That would be 31, 30, 29. So our X should be 29 in there. And it's not. So Why is it not? The only thing I can think of is that we're missing something at the start here. So I don't want to go back and like second guess our things, but we need to make sure that we have the right number of values here. So if we've imported the correct number of keys, let's draw the keys on screen. Okay, so if we go to our room renderer, so our room renderer, that's our portal there. If we do for each bar key in keys, room key, what are they called? Oh, data, that's why. Data dot keys. Okay. So I'm going to create just a red square. So I'm going to do byte key shape equals new byte 255 255 255 255. Helps I put it there. And what? And then I'm gonna say screen.drawSprite. Actually, I'm gonna do screen.setAttribute, and then it's gonna be key.position.x, key.position.y, and then my attribute is gonna be red ink, black paper. I'm going to make it bright, and I'm going to make that non-flashing, and that should be good. And then I do screen.drawSprite, and then the sprite is going to be our key.position.x, key.position.y. I'm really only doing this for debug because we're going to change the room shape anyway, but if we get it in just now, then that's good. Number of columns is 1 and 1, and then our data is going to be key shape, and this should give us a red block where our keys should be, and we know that our keys should be in this sort of space here, so they should be in this location here for central cavern. Okay. We have a key, and it is not in the right place. We have no other keys. Why do we have no other keys? I'm going to set a breakpoint on there. Actually, let's set a breakpoint on the actual room keys themselves. This video is going to pot. I do apologize. This is what happens when you take a break and not look at your code for months on end. In fact, I'm going to have to take a break in a couple of seconds anyway, because this is coming up for an hour. Okay. Okay, well, that's not good. I'm assuming that's terrible then. Because that continued straight out the bat there, and that's not right. So room keys is 4. Well, okay. So there should be 4 room keys. 28 and 2. That seems right. So why is that not displaying correctly? 28 and 2. I think that might be. Yeah, that's 31. That's 30. That's 29. Okay. Right. End of part 1, I think. So I've done some debugging, and I think what the problem is this line here. So this is the continue. If it doesn't continue, then it doesn't read everything, and it doesn't move on to the next number of bytes. So what I'm going to do is I am going to add bool add key, and I'm going to set that to be true. And then I'm going to set this to be false. I'm going to set add key to be false if we're not going to add any values. But we still want to read those values in, because what I found was at this point here, this red breakpoint line up here, everything was fine. That the offset from the start of the read to the end of the read of the stream was fine. But when I get down to here, it is 649, and it should be 655. So I'm going to make these changes, and then we're going to see what the offset is once we do this. So if I leave everything as is, and I attach it, when we run Manic Miner, right? Okay. So that's that one there, and then at this point here, and then this is the right position. So if I hover over importer and then go to there, you see the position is 299, and if I take away our start position from that, 29299, subtract, what have we got here, 28762, I get 627, which is the offset of our border color, which is right. So at this point it's right, but when it gets past this part here, it misses all these reads and it gets out of sync. So what I'm going to do is I'm going to add this flag in here. Where do I put my flag? Okay, add key equals true. I'm going to set that to be false. I'm going to set that to be false. And we could probably combine these two, but I'm just going to leave them as is just now. And then I'm going to say if add key, add the key. And if not, we don't add the key. So this is where we sort of go from being sort of our sort of low-level programming type thing to our sort of high-level programming type thing, paradigm, whatever you want to call it. But we're just adding them to a list, and then we finish them. Forget about that, but it's fine. Okay, so now if I attach to Unity and we run this, we should hopefully, when we get to portal, that's our items there. So when we get to portal, the offset should be 655. That's what I'm hoping anyway. So run this here, and we get to here. So our importer is at position ms, and it is that there, and then we subtract that from our initial position, which is 28672, and we get 653. We're so close, so close. You can almost touch it. Which means that we're now 2 bytes out. So we have the right position. This is the right position here, but we're not getting the right attributes. So that's the right position, but it's not the right attributes. Okay. Why is that not there? I mean, what I can do is I can skip a couple just to test it out. So if I do importer.read bytes, and then I just skip 2 bytes, total and utter hack for now. I don't know why we're missing 2 bytes here, but we'll come back and we'll make sure that's right. And then there. Oh, well, okay, so now we have the bytes right, but we don't have the position right, and the shape's wrong as well, but the attributes are right. I'm pretty sure they should be flashing as well. Okay. Alright, so some more debug information. Debug stuff going on here. Alright, so we're going to get to 655. Why is this? Oh, okay, wait a minute. Oh, okay, these aren't read in multiples. These are read outside of that. So that is read outside of there, and so is another one. Where's the other one? So first byte of each item, second, third, and fourth bytes, and then the fifth byte of each item is always set to that. And then it says offset. Okay, so that is, well, let me just put this in here, just so we know where it came from. Appendix F. A bit of text here, but this is so that we don't need to keep looking it up. So our let's do read byte, read, and this will be D2. So he says that offset 654 is always set to 255. So D2 should contain 255 if we've done this right. If we haven't done it right, then it will be wrong. That's right, I said that. Okay. So D1 is 255. And our importer is at position. What is our importer? Our importer is at this position here. And this position minus our start position, 28672, is 254. So that one's 255. Okay. So our portal color is 14, which is OE. Okay, that looks okay. And OE in programmer. Hex. OE. Where does it used to say in binary? Oh, there it is, a binary. So that's 0, 1, 2. So 1, 2 is 0. So it's 1, 2, 4. So that's yellow. And then that'll be blue for the other one. Okay. So that is yellow and blue, which is right. So it's yellow ink, blue paper. That looks okay. Not flashing though. So I don't know why there's no flash on there, but that's, you know. What are you going to do? Bit of a fudge because we're going to ignore the first short, okay. But I don't think we do ignore the first short. So the position here is going to be that. And then our temporary position is going to be 29, which is right. And then our Y position is going to be 5, which is way wrong. So yeah, 5. So is it 5 from the bottom? Because that would maybe make sense. 0, 1, 2. That doesn't even make sense either. I don't know where they're getting the 5 from. Unless we're getting the position wrong. So according to this, where are we? Portal. No. Portal. Offset 688 to 691 represent the position of the portal. It's a 32-bit word in the following format. So the word is all of that, but these are actually repeated. So you see here that you've got, they're sort of repeated, I should say. So the first one is that one, and the second one is that one. Oh, wait a minute. Y is the vertical position of the portal, and XXX is the horizontal position. .0.0y refers to the secondary graphics buffer. And secondary attributes buffer. Secondary graphics buffer. Secondary graphics buffer. Background graphics, secondary graphics buffer, secondary attribute buffer. I've since discovered that the bit pattern for the background graphics buffer should be that, or YYY is the number of pixels below the specified character row. So the vertical position of a conveyor animation can be given in pixels, not just characters. The bit pattern for the secondary graphics buffer is allowed to specify the vertical positions in pixels. However, there are bugs associated with this, so it's not recommended. Manic game engine doesn't cover the 3 character rows. What is okay, so maybe we just read, maybe it's the other way around. Maybe it's the other way around, and then that's maybe getting the wrong values. It was the other way around. Okay, so now we have that there. That's not the right images though. That means we need to sort the block data for that. Okay. We're going to ignore the second short. Because it's the attributes, so we don't really need to know the attributes because we've got the X and Y position. We can calculate that. Okay, so we've got that there. Portal shape is wrong. Why is portal shape wrong? It looks like it's getting some of the right values, but just not putting in the right order. So that looks maybe like it's going like striped. So it's like that one, then that one. Maybe we need to do a different portal render. Oh, actually, I think we've already got that covered. So inside the room renderer, I can do screen.sprite, row order sprite, column order sprite, row order sprite. So I can set that as a row order sprite, and then it will draw the right way around. or not draw anything. Column order. This is part of the changes I made off of camera. Well, not off camera, but that I lost. Okay, so it's column order. It's just that row order, but row order's not working. So row order is that. Draw sprite. Most and least. Okay, so why is this not drawing that? And you've probably noticed that I have changed my shirt. Alright. It's a different day. It's like 2 days later. That was the Canada Day long weekend there. We celebrated Canada Day. There was fireworks, there was a barbecue, and good times. So, I want to go over here. This is the draw sprite thing. Now, I think the problem is that this is the way that it should go. So, I think most and least. think this bit here is wrong, because when we run it, you'll see that we end up with with nothing there. And I think the reason is because if we go to Room Renderer, actually go to here, and Room Renderer, and then this is Draw Sprite here, and if we comment this code out here, that one line, then we get this, and this line should be up here, and so on. So what I think it should do is, instead of the row order sprite, so this is going to be that, and I'm going to say row order sprite is that. Okay, so we don't want to do all of these at once. What we want to do is, I want to say if sprite format equals column order. Actually, I don't want to do that. Maybe I actually want to do this as two separate functions. So I think what I might do is I might do that. So I want to say if sprite format equals sprite format column order sprite int x int y. Oh, sorry, that would be x y calls rows data. So I just want to put this in just now, and again, I want to reiterate that I get a lot of comments in the code that this is not how someone would do it. Again, this isn't necessarily the right way, but it's the functional way of doing things. So when I write something in here, this is like my first draft, and I'm leaving up to you guys to go and tidy it up and make it better. So just to let you know that this is not the most optimal way of doing things, or possibly the optimal way of doing things, but it's optimal enough for right now. Actually, I can just do generate that, and then we'll paste everything inside there, and we'll just leave this. This was the old draw sprite. Let's leave it as is for now. So we will make that the old one, and we'll put it way down here because this is where all the private stuff goes. And then up here we will then do else draw row order sprite x y calls rows data. So we need to do one that is going to go from left to right, but it's going to alternate the rows. Okay, so I think I need to do for int x equals x, x is xx is less than x plus columns, xx plus plus, for int yy equals y, yy is less than y plus rows, yy plus plus. So kind of standard for loops there. Then I want to have a row counter, or actually that should be current row is that, and then for, actually this has got to be switched around, hasn't it? It's got to be that way around, because we're going to do it for each of the y values, because we want to do that, and then for, how is this going to do this? So for each of the y's, I want to go and do this column, then that column, this one, that one, and then I want to do, actually do I want to do for int row equals 0, row less than 7, row plus plus. Do I want to do it this way? I don't want to do it this way. Maybe I don't need current row, because I need to have it so that it does this line, then the next line, and then I want it to move down to the next row and do the next ones there. So I think it's this one. And then this is going to be the same as the one down here, which is poke. And that is going to be, instead of ing, that is going to be xx, yy, and then it's going to be row, and then it's going to be the data, which is the row plus the offset. What is offset when it's at home? Offset is 8. So I don't think we need the offset there. I think we just need to have it as data. Actually, no, we do need to have offset. Offset. So we add 8 to the offset. So I'm going to do 1, 1, 2, 2, 3, 3, 4, 4, 5, 6, 7. So let me just leave that as 0 just now. And let's see what we get. Hopefully this is a little bit better than... Oh, and we also need to do set the sprite format here. So this is going to be row order sprite, and then we draw the sprite. Okay. So this should, I think, give us the right one for the first half at least. Okay, well, not entirely. Sure what the format is for this. Format. Okay, so portal. So portal is that 16 by 16 graphics, see appendix C. Appendix C, okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So represents a sequence of that. Start with your understanding of 8 by 8 graphics, where a byte represents a row of pixels. In 16 by 16 graphic, the bytes number 0 to 32 are aligned as follows. So 0, 1, 2, 3, 4, 5, 6, 7. So I am doing it as maybe I just have that as an index. So if I do int index equals 0, and then that's going to be index plus plus. And we just add 1 to it, and then we just keep adding it that way rather than trying to be clever about it, because we're going to do that for each row. So that's going to give us 0, 1, and then the next row is going to be 2, 3, 4, 5. So that's 1, 2, 3, 4, 5, 6. I think that should be us. So fingers crossed. Woot. So yeah, just a little bit kind of screwy here. But yeah, that's looking okay. That's the portal there. Let's see if we can figure out that. So that line there is blank, and that line there is blank. So that should be 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that should be colored in. Let's see why that's not colored in. So index is that. So 0 to 32. So our x, y, y. It's columns. I guess columns is renderer. Number of columns is 2. Number of rows is 2. Wait. That's gotta be... No, that's right. So that's the number of... Yeah. Okay. Oh, less than 8. What a buffoon. Okay, there we go. So rows less than 8 because it's 0 to 7. For all of you screaming at the screen, thank you. Okay, so now we should have a fully working portal. There we go. Wow. Okay, and then we can do the same thing for room 2. Let's see what cold store looks like. Awesome. And then let's just pick a random room. And 6. Yeah, there you go. There's the random room there. So we'll choose one more as well, number 9. And yeah, it looks like a door. Perfect. Okay, so we're getting there. That's it's looking good so far. Okay, so in the next, I'm gonna go full screen here. Okay, so in the next video, what we're going to do is we're going to look at getting in the bad guys. Oh, actually, no. Wait a second. We started looking at getting keys in, so let's see if we can get the keys done first of all. Let's go back to here. Okay, so that was the draw there, and then for the keys, where are we? Room renderer. And then we had this one here. Was it add sprite? Is that what we had? Well, we had add sprite, but we don't need add sprite anymore. So what we can do is we can do for each our key in data.roomKeys, and then we can do screen.draw sprite, and then it's going to be our key.position.x, key.position.y, the number of columns, which is 1, number of rows, which is 1, and then it's going to be key dot, actually it's not going to be that, it is going to be item shape, I guess, room key temp. That's not right. I guess we don't read it in. I think that's the problem. So this is the room renderer. So this is just going to be data.room room keys. Oh, we don't read the room keys in. Haha. Hang on a sec. So inside, where are we? Room data. Yeah, room data. We have that there. And then we also need to have public byte, and then that is key shape. And we'll set that to be get set. So now all we need to do inside here is data.keyshape, and that will then draw each of the keys in the room. And then we need to set that, and we do that inside our snapshot import. No, not snapshot importer. Our room store. Okay. And then we have add portal, and then after portal, what do we have? We have portal. Then we have item graphic. Okay, so portal, and then we have item graphic. So if we go to item graphic, item graphic is just the item graphic. Okay, so we can just do data dot that would be key shape equals importer dot read bytes, and then we're going to read in 8 bytes. So now we should have the portal, and we should have the keys displayed on the screen, hopefully at the right position. Hopefully everything's hunky-dory. Fingers crossed. Ah, no keys. Why no keys? Are we drawing the keys? Let's do that there. Let's set a breakpoint there, and then also in room renderer, we'll set a breakpoint there. And we can get rid of some of these as well. Actually, we'll leave that in for next time because that's kind of good placeholder. Comments. Okay, so our importer is there, so I press F10 for key shape, and the key shape looks like that, which looks okay to me. And then the room keys, there are no room keys. Well, that's why there's no room keys getting shown. Did I comment that? Room store. Oh, right, okay, so that's why. So I need to do add key equals true. So every time we go through that loop, I have to make sure that the add key is true, because if it gets set to false, then we're going to get no keys. So now we should have some keys in the room. Okay, I'm going to set a breakpoint there. And then I'm going to run it. So close. I just want to get this little bit done, and then I can finish off this video. I can edit it, and I can put it up, and you guys can comment about how bad it is. Okay. So inside here, my room keys. I have no room keys. Why do I have no room keys? Okay, now I have to do further debugging. This is no good. Okay. All right, so let's run this. All right, so attribute 0, so we don't add anything. So we do that, and then we say add keys equal to true, and then attribute is 255. So we don't add anything. Attribute is 255. Why is attribute 255? What? This was working before. So these are the dummy ones. They're both 255. And then I've got my portal color, which is 14, which is right. And then portal shape, which is all of these, which look okay. And then I get my portal. So why am I getting my keys there? So the border color should be 2 because it's red. 1 is blue, 2 is red. So border color is 2, that's right. So add key. So I read the attribute. That's 0. And then that's 9 along, 0. See, I think that's right. I think attribute is. Let me comment this out. I'm gonna go back and read the docs there, but the 0 and 9 looks like it should be valid. 255 doesn't look like it should be valid, but 9 looks like if I look at central cavern, and then I look at images. Do you see what I mean? I mean, this is the Commodore 64 version, but that's terrible. Why did I do that? Oh, I'm in Bing, that's why. Okay, here's Central Cavern. Oh, I don't want to save image. I just want to zoom in. Why won't it let me zoom in? There you go. Okay, so here's the source image here. Oh, I think this is from the Game Boy Advance version. Okay, so look, right there. There's a key. Right there. It's the wrong color, but it's the key there. Actually, why we are drawing. Hang on a sec. Room keys. We do draw that. Oh, where's that debug info? Yeah, this is it here. Yeah, we did draw it there. So I'm going to set that to be nothing, and then put that in there, and then I can get rid of this here. Okay, so hopefully we should have a key for the central cavern now. There you go. We've got a key, so that's right. But we're missing the other keys. So we have a key there. Let's go back and look at the keys again. Item graphics, portal, items. 5 offsets. Okay, I think what we need to do, each represented by 5 bytes, I think what we need to do is, instead of having that there, we do it's 5 there. So read it there. So 5 bytes. First item if present, second item if present. So fewer than 5 items in the room, and pad out the item after the last item. Okay, so that's kind of housekeeping stuff. We're not really interested in that from our point of view. The 5 bytes. Okay, so there's going to be 5 bytes. That's 1, 2, 3, 4, 5. There's 5 bytes there. Oh, am I missing something? We've got 1 byte, 2 byte, 3, 4, 5. That's 5 bytes. 28 to 54 is 25 objects. Everything's an object. Up to 5 items can be stored. First item, second item, third, fourth, and fifth. 4, 5. There are fewer than 5 items. 5 bytes. First byte represented by color attribute. An item should not have a color of attribute of 0 or 255. Set an item's color of 0 removes the item, and setting it to 255 terminates the sequence. Okay, so let me. So right now it's wrong because we're reading in the 0 value, but it's the only way to get that 1 to show. Okay, so attribute is 0. Yeah, so that's 9 and 0, which is right. And then the next one is 29 and 0, which is also right. Why is that key false? That'll beat to phone. Right, okay, so the numbers are looking good. Key position is 16 and 1, which is right. But add key is set to false because all the attributes are 255. Why are the attributes 255? What if okay, let's just hack it. Okay, let's not have attributes in there, and then let's see how many keys we get. Why? So, that's right, isn't it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, that's right. 1, 2, 3, 4, 5. So what's this stuff about 255? Well, we'll have to figure that out later on. But okay, so we have these keys. We have the portal. I think that's a good. In fact, I'm going to stop that and get a screenshot. I think that's a good enough time to quit, I think. So there you have it. That is what we have so far. So next time we're going to get moving mobs. We'll call them mobs. In there, we'll also try and do some of the animations of the keys because they should be sort of sparkle. And also when the portal finishes, that should have the flashing attribute set to it as well. I haven't actually showed any of the screen thing, but all the screen functionality all works. If you set something as being flashing, then it will flash. In fact, I can set this to be, I can show you that, I think. If I do, where are we? In the renderer, room renderer, yeah, here we go. So for here, I want to set the attribute to be flashing. So this is the portal. So I want to say data.portal.attribute.flashing equals true. So I want to set that portal flashing to be true. So when we run this, this is a live test. So hang on a sec. Let me do that again. So I added this one line here. I'm going to take it out in just a sec, but it's just to show that hopefully it runs. And we end up with flashing. So there you go. So there's the flashing portal there. So all of that functionality, that all currently works. So all the attribute clash, everything like that was all done in the video that's lost, and I was bawling my eyes out and all that kind of stuff. So these things are sent to tries. So that's the state of play so far. So next video, which hopefully I won't leave too long. I've split this video into two, or I will split this video into two. It's a bit of higgledy-piggledy and less edited and things like that because time's been kind of short and things like that. So I apologize. It's not my usual polished professionalism, but it's just been a kind of a crazy couple of weeks. So. Yeah, so again, thank you very much for keeping with me in this one. This is more a labor of love than an actual kind of practical thing, I think. But I'm kind of leaning towards doing like a ZX Spectrum emulator inside Unity, which I think might be quite kind of fun to play around with. And I also have another couple of ideas as well that in addition to the ones that you guys have sent in as well. So there's plenty of ideas in the hopper for later on. But yeah, thank you very much for watching. I do appreciate your time, your viewing. If you like this video, then feel free to share it. Feel free to share any of my videos on social media. Drop me a like or whatever, and subscribe, and don't forget to hit that little bell, and that'll let you know when I don't know why subscribe doesn't work. I don't know why you have to do 2 steps. I still don't understand this. YouTube, if you're watching this, and chances are you're not, why do you have to hit subscribe and also the bell? I don't understand. Why? I don't know. It's like, I don't know, just weird. So if you liked the video, thumbs up. If you didn't like the video, thumbs down. But please feel free to leave comments, concerns, questions, that kind of thing. And I will catch you in the next video. Thanks. Thanks again for watching. Bye-bye. So today's the official Canada Day, but July 1st is actually Canada Day.